Hello and welcome to a video. This time doing a couple of questions for Naveli. She's obviously loves planes and matrices as much as I love planes and matrices, because she's given me a couple of questions on this. This one looks familiar. I'm sure I've done it before. I can't remember when, but hopefully I haven't already done a video and I'm doing it twice. But I'm settled now to do it, so let's get on with it. Okay, so first question. Now this is interesting. They don't give you much here. They just say 10 marks. I find it interesting because I find there's quite a big restriction on K in the fact that it can only be the number 4. But I'll show you how I came to that conclusion. Basically, if if you can find the intersection of three planes, then either they intersect at a point, yeah, or they intersect in a line. Now, if we investigate the discriminant of the matrix, yeah, let's investigate the discriminant of this. 1 minus 3 minus 2, 2 minus 2, 3, 5 minus 7, 4, yeah? If I investigate this matrix, well, if the discriminant isn't 0, then sure, they intersect at a point. But if the discriminant is 0, then I'm afraid more investigation is needed, if you like, because perhaps they intersect, perhaps they don't intersect at all in any common point or common line. Perhaps they intersect in a line. Perhaps they form like a triangular prism. Maybe some of them are parallel. There's lots of possibilities, basically, if the determinant is 0. But given that they're saying the planes intersect, there's really only one possibility. Well, there's two possibilities. Either the planes intersect at a point and the determinant isn't 0 and the matrix is not singular, or they intersect in a line and the determinant is 0 of the matrix. So let's actually investigate that. Let's find the determinant. The determinant, if we call this A, the determinant of A is going to be given by 1 times by minus 8 minus 21. Well, minus 8 plus 21 is 13. And then we're going to do minus 3, which is going to become plus 3, times by 8 minus 15, which is minus 7. And then we're going to have minus 2 times minus 14 minus 10. Minus 14 minus 10 is minus 14 plus 10, which is minus 4. Yeah. What do we get here? We get 13 plus 8, which is 21. Take away 21, we get 0. I was pleased when I saw that because I thought, oh, well, that's really handy, because that means that the planes must intersect in a line. They can't intersect in a point. So that was interesting for me. It narrowed down the possibilities really nicely into, okay, there's only one possibility. If they do intersect, then they must intersect in a line, something like this. Then if we had another plane like here, it's really hard to draw. You can see why I use GeoGebra a lot. I'm not that good at drawing. Maybe if I drew it more like this. Yeah, that's better. Okay, so they're going to meet in a sheath, basically, and we're going to find the equation of that line. That's what we need to do. So in order to do this, I certainly don't do it like I've seen the textbook do these questions, and I think they make a real meal out of it. I think I've got a much nicer way of doing it. Let me give myself a bit more space. Now I've discovered that's definitely the situation. I can. Right, so let's now look at A, B, and C. Yeah? If we eliminate X by doubling A and writing down B underneath and subtracting, what do we get? The 2x's cancel. Minus 6 minus 2 is minus 4y. Minus 4 minus 3 is minus 7z, and that equals 3. In other words, 4y plus 7z is minus 3, but I'll just leave it like this, yeah? Now that's with A and B. Now you should get exactly the same result when you're looking at A and C or B and C. I think it's probably easier to use A and C because I'll just times it all by 5. And then write down C underneath. And I'll subtract again. Minus 15 minus 7 is minus 8y. Minus 10 minus 4 is minus 14z, yeah? I was very happy when that was a multiple of that, yeah? And then that's going to equal k minus, which way round did we do it? 10 minus k, yeah? And now if we halve everything, we can say, okay, minus 4y minus 7z is 10 minus k over 2. So yeah, there is a restriction on k, a very strong restriction, which is that 3 must be equal to 10 minus k over 2. If you get inconsistency here, yeah, then the planes don't intersect and you've got the prism kind of thing, yeah? Do you know what I mean by the prism kind of thing? That's where you've got plane here, plane here, maybe a plane like that, yeah? And then maybe a plane at the bottom, something like that. I hope you see what I'm trying to draw here. When you've got that kind of thing going on, where the planes kind of intersect in 3 distinct lines, but they don't agree on any one line, that's where you'd have 3 and this is something entirely different. The planes would not intersect in any common places at all anyway. So I think the planes do intersect in a line, provided 3 equals 10 minus k over 2, or in other words, 6 equals 10 minus k, or in other words, k equals 4, yeah? So k equals 4, then they intersect. Yeah, they have a common point of, they have a common place of intersection. Well, it's a line, isn't it? A common line of intersection. If k wasn't 4, then they would have no line in common where they intersect. It would, in fact, be this situation where you'd have these two agree on that line, these two agree on this line, and these two agree on this line. Okay, so we've got k equals 4, but they didn't just say find any restriction on k. They said find the intersection of the 3 planes. So we need to find the line where the 3 planes intersect. Now, this is the fun bit. Now we know that k equals 4. Okay, if I want to find the line where they all intersect, this is what I do. I literally make it up as I go along. What I'm going to use, actually, because I've already done some of the hard work here, I'm going to use these equations. I'm going to use this equation here, and I'm just going to say, okay, if y equals 1, then I'm going to have minus 4 here. Add it over here, I'm going to get 7. So z will be minus 1, yeah? And then plug it back into the top equation, and you're going to get x equals 3, yeah? That's nice. Okay, so I found one point on my common line of intersection, yeah? This point, you can check if you like, should agree with all of those equations. Let's check the bottom one. 15 minus 7 is 8, minus 4 is 4, yeah? Let's check the middle one. 6 minus 2 is 4, minus 3 is 1, yeah? It just works, yeah? That point lies all 3 of those planes. That's kind of good. Let's do it again. But let's pick a different value for y, because I'm just picking an arbitrary value here, but I pick so the numbers work out nice. I think I eventually decided on z equals 7 after having a look, because that makes that minus 49. Add it over, you get 52. Divide it by 4, minus 4, sorry, you're going to get minus 13 for y. And when you plug x in, you'll see it's at minus 23. Yeah? Because the reason why I've done this is I've now found 2 points which lie on all 3 planes. That must be the line of intersection, mustn't it? And so I can now write the vector equation for the line of intersection. It's just going to be 3, 1, minus 1 plus lambda 7 minus 13 minus 23. Yeah? And oh, sorry, no, I've got this. What am I doing? You don't just stick the other point in, you find the vector. Okay, so from going from 3 to minus 23, that sounds like minus 26. Ooh, a bit messy. And then going from 1 to minus 13, that sounds like minus 14. And then finally going from minus 1 up to 7, that sounds like positive 8. We can, of course, simplify that to r equals, let's simplify it, half everything, minus 13, minus 7, and 4. Okay, I can actually check my answer on these questions. That's what I really like. Let's check it in the middle one. Yeah, this not only should lie on the plane, but it should lie completely in the plane. So if I plug this in, it should be absolutely making the whole equation true. So it's 2x minus 2y plus 3z. This is just how you check your answer. 2x minus 2y plus 3z. And what does it equal? It equals 1. Yeah? Let's see if this completely satisfies this equation for any value of lambda, because that means the whole line lies on it. 2 times 3 minus 13 lambda, minus 2 times by 1 minus 7 lambda, plus 3 times by minus 1 plus 4 lambda. Okay, let's see what this equals. 6 minus 2 is 4, minus 3 is 1. And then you're going to get minus 26 lambda plus 14 lambda plus 12 lambda. And 14 plus 12 is 26. So you just get 1 equals 1, yeah? And hence it looks very, very good, this equation. I didn't make it clear whether they wanted the line of intersection of the three planes given like this, or in the Cartesian format, you know, x minus 3 over minus 13 equals y minus 1 over minus 7 equals 7, z plus 1 over 4. Yeah, however they want the thing given. They might even give it parametrically. They might write as a coordinate of 3 minus 13 lambda. You know, this is definitely a possible 1 minus 7 lambda. Minus 1 plus 4 lambda. Let me know in the comments if they've left it in a different way, or indeed if I've got the answer wrong, but I'm really sure looking at that I've done a lot of things right here. But you can check it in all three planes in the exam and just check that it works. So that's that one. And then you gave me this one, and I quite like this one because this one's a good one for checking as well. Once again, what I did first, I thought if I want to transform this plane to another plane, then every point on the plane will be in the transformation. So the first thing I did was I said, well, let's find 3 points which are on this plane. Yeah. So I think I went with, if x is 1 and y is 1, then z would be minus 9. And then I went with, when x is 2 and y is 2, z would be minus 6. And then lastly, I went with, when x is 3 and y is 0, you definitely don't need to use these ones, then z is minus 6 again. Yeah. So, and then I thought, right, I'm just going to take C and I'm going to find out where these 3 points map to after this transformation. So I multiplied it by, let's not write C equals, let's just multiply it by, and I wrote this one as a column matrix as well with like 1, 1 minus 9. That's my first coordinate. If you like, this is A, B, C, and it's going to equal A dash, B dash, C dash, you know, where the points have transformed to. And so 1, 1 minus 9, 2, 2 minus 6, and then 3, 0 minus 6. Okay, where do they go? 1 plus 2 is 3. Okay, I did this earlier, and I hope I got it right. We'll find out at the end because I've got easy ways to check. You'll be able to use your calculator, but Corrida's still got my calculator. I know I keep mentioning that in videos, but, you know, just in case he's listening out there, thought I'd, you know, throw it out there. I don't mind, I really don't. It's good for me to not use the calculator. Okay, so that's what I get. So I now know where my points end up. And so all I've got to do now is take these 3 points, 3 minus 8 minus 7, 6 minus 4 minus 2, and 3 minus 3 minus 3, and find the Cartesian equation of that plane, yeah? Okay, well, let's do it. That's the standard way of doing this would be to write down 2 vectors in the plane. First vector is going to be 3, 4, 5, and then I'm going to have AC. AC's vectors are 0, 5, and 4. Okay, and we're just going to do AB cross AC so we can find the normal to the plane. I, J, K, 3, 4, 5, 0, 5, 4. Now be really careful when you do this. I suppose you'll do it on a calculator, but if you do it in your head, you're probably like, well, maybe you're not like me, but I make careless mistakes when I do these things all the time. I really do. Just sign error mistakes and stuff like that. But I've got a very easy way of detecting at the end. Okay, right, so we're going to do 16 minus 25, well, that's minus 9. Then we're going to do the minus of 15 minus 0, well, that's minus 12, sorry, minus 0. See, yeah, there's a mistake. That's minus 12. And then lastly, we're going to do 15 minus nothing, that's positive 15. Cancel that down as well and point out that minus 3x minus 4y plus 5z equals some point D. And now we do have some points which lie on this plane. So let's use 3 minus 3 minus 3. That's going to give us minus 9 plus 12 minus 15. Okay, what does that come to? Minus 27 plus 12. I think that's going to be 15, isn't it? Minus 15, sorry. No. Minus 9 plus 12 is 3. And then if we take away 15, we get minus 12. Yeah? Blimey, really struggled there. Okay, so I think my equation of my plane is minus 3x minus 4y plus 5z is minus 12. Now, there's an easy way to see if I've made a mistake, which is to plug another point, this point. If I've got minus 18, I'm plugging in this point, and then I've got plus 16, and then I'm plugging in minus 2, minus 10, yeah? I've got minus 12. Yeah, that one works. And it's the same with the top one. If I have minus 9, and then I have plus 32, and then I have minus 35, yeah? Sure enough, minus 9, 32 minus 35 is minus 3, and minus 9, you get minus 12. So all the points work. But that does not prove that I didn't make a mistake earlier. It just proves that I've definitely, this is the right plane for these 3 points. Maybe I made a mistake when I did the matrix multiplication. Well, to check that, if you want to check, if you really want to make sure, let's just find another point on this line. Let's try 0, 0, minus 12, because that's quite obviously satisfying that line. If I times that by 0, 0, minus 12, it should be relatively easy to quickly come up with the answer, because I've got lots of zeros in there. I'm going to get 0, minus 12, minus 12, yeah? So that transforms to that. So this point, this 0, minus 12, should lie on this plane. I wonder if it does. Let's have a look. 0 plus 48 minus 60. Does that equal minus 12? Yes, it does, yeah? So I'm sure I've got it right. Okay, Naveli, hope that helped. Hope it was useful. And yeah, keep up the great work. You're doing really well. Bye-bye.